We'll do section 4.1 in a couple lectures. The first is a linear model, y equals mx plus b, and we've studied those quite a bit. What we need to realize about a linear model is that it has a constant rate of change. And that constant rate of change is really m. So when I took a look at a graph here, it is going up by the same rate, that constant rate, throughout the whole graph. Now, exponential model is a little bit different. It has the formula y equals a times b to the x. And I shouldn't really call it a formula. It's actually a model. That's how we'll look at it mathematically. And we need to define, just as we've defined up here, m as being my rate of change and b as being my y-intercept, we define below here a as my start value. In other words, it's also called my y-intercept. So if you notice, it's similar to b in my linear equation. B is my factor. Now, b in my exponential is different than b in my linear. B is my factor. It is how fast, or my multiplier of growth. It is made up of 1 plus the rate. So if we recall back when we did the skittle or skeeter module, the one said keep 100% of the population, and rate is also a percent, and add to it whatever percent of growth that you might have. Now, not everything grows. If I want this to decay or be less than, then I might have 100% minus 3%. So here my factor in the first situation would be 103%, or 1.03, converting it to a decimal. And in the second situation where I have decay, I'm losing 3%, so I stick with 97%, or 0.97. Notice, this b value is less than 1 when I have decay. The b value is less than 1 when I have decay. So right here, we're going to say b, my factor, is going to be less than 1 when there is decay. When I have growth, my b value is going to be greater than 1, or my factor will be greater than 1 when I have growth. So decay happens when your rate is, or r is negative. Growth happens when r is positive. And the last thing is x, and x is just the exponent. That's why we call this thing an exponential. Its graph looks quite a bit different. So let's take a look at the graph of something that shows growth. Something that shows growth in science, sometimes you call that a J-curve, where this position right here is my start value, also known as my y-intercept, or in this problem would be a. And then the shape of this, how steep it is related to who's ever attached to x. What do I mean by that? Well, when we go back up here and look at m, if m is a large number, I'm very steep. If m is a small number, I'm slanted. So this is small and this is steep. Well, that kind of goes in the same thing with my r and my growth. If b is large, notice who's b with? B is with my x. B is with my x. It kind of acts as my steepness. So we have some similarities and differences here with these exponential and these linear. First of all, they both have a start value. And another name for that, the formal name would be your y-intercept. I know that I go to the y, and that's where my first location is going to be. The differences is that the exponential, because it's an exponent, is multiplicative, meaning I'm multiplying to get to my next item. So it has faster growth. That results in faster growth. Where linear is additive. It's got that same the same thing every time. Obviously, if you have money, you want it to be multiplicative. So there's an introduction to exponentials. Again, it's a review. Next lecture, we'll talk about the graphs of exponentials.